All right, so as I mentioned, this section for you guys is 6.1 lines and angles. It starts off, with a few, when I was looking at the homework, it has a few like definitions. So in other words, it says what's a line, and so this is a line, and they have segment is a line with two endpoints. So that part, you guys pretty much, it's just a definition. So if you have any questions on it, then feel free to get with me. But when I looked at them, I was like, that's pretty much straightforward. So we'll get into some of the exercises. Make sure we're good with that. So here, the first one, X, Y, and Z are all on line L. Given XY is 9 meters and YZ is twice XY, find XZ. All right. Well, you guys copy that. I have one of your classmates trying to get in, trying to figure out why he cannot. All right. So it says XY is 9 and YZ is twice XY. So find XZ. So this is the diagram right here. And so we see this piece is 9 and this is twice that. So a couple different ways you could do it. But we see that, let's say if we set it up as an equation, XY plus YZ is equal to XZ, that whole segment. And this is the way that it's given to us. We have XY, then YZ is twice XY. All right, so we have XY is 9, so 9 plus 2 times 2 times 9. 2 times 9 is 18. So that means XZ is 27. All right, questions on that? All right, so the next one, A, B, C are all on line L. Given that BC is 16 feet, AB is equal to 1/4 of BC, find AC. So same type of deal, just making sure we're okay with concept. So BC is 16 and AB is 1/4 of that. So we see that AB plus BC is equal to AC. All right, so plug in the pieces. We know that AB is equal to 1/4 of BC. BC is 16, then 1/4 of 16 is 4. So we see right here in the red, I did the work, 1/4, 1/4 times 16/1, 16/4, which is 4. So it means AC is 20. Sorry about that. Like I said, I'm trying to have one of your classmates trying to get in here, and I can't figure out why he can't get in. All right, questions on that? Are they okay? All right, so lines that never touch or cross will be parallel lines. Perpendicular lines. Oh, let me say that. And these, example of parallel lines are right there. Just lines that have the same slant or slope. All right. Perpendicular lines are lines that create a 90-degree angle at intersection. And you can never assume that you have perpendicular lines, never assume that you have 90 degrees in between your lines. And so you have to either see that red square or it has to be stated in the directions that, this is 90 degrees. All right. Body okay. Of course, if I scroll up too fast, let me know. Next, we have angles. Two rays with the same endpoint is an angle, and that endpoint is called the vertex. All right. There are four basic types of angles. An acute angle is between 0 and 90 degrees. Right angle is exactly 90 degrees. All right. All right. So obtuse angle is between 90 and 180 degrees. And a straight angle is 180 degrees. Might have 360 in there too. Yeah, rotation. All right. A full rotation or revolution is 360 degrees. All right. Any questions on those types of angles before we go any further? Make sure we're good. All right. Complementary angles. two angles that add up to 90 degrees. So 50 plus 40 gives you 90 degrees, so they're considered complementary. 1 and 89 gives you 90 degrees. They are considered complementary as well. Supplementary angles, two angles that add up to give you 180 degrees. So 150 and 30, 2 and 178 will be considered supplementary. All right. Everybody good? Scrolling up. All right. So next example says, given that when you see the symbolism right here that represents the measure of, given that the measure of A, B, and C is 84, find angle X. So this is the diagram right here. So you were talking about walking through it. I'm going to put this stuff back up here, though, of course. You would establish, or this is how you visualize it, whether you write it down or not. Angle X plus angle plus 47 is equal to 84. They gave you the fact that this is angle X, and they will give you the fact that this is 47 degrees. When they tell you the whole thing is equal to 84. All right, so let's walk it back. So you would just subtract 47 from both sides, and you'll see that 37 is equal to both. 37 is equal to X, angle X. All right, so everybody good on that one. Everybody's copying. All right, so vertical angles. They're formed by two intersecting lines. Oh, I was just say formed by intersecting lines. I won't say necessarily two. I won't say just two. Anyway, I didn't write it, so it's all right. So formed by intersecting lines. The non-adjacent angles are the vertical angles, and they are equal. That's why they are important. So here, if we have lines intersecting, angles 1 and 3 are considered vertical angles. They are equal to each other. Angles 2 and 4 are vertical angles, and they are equal to each other. Then what the? I'm sorry, y'all. Oh, okay. That makes sense. All right. All right. Let me erase some of this stuff so we can walk through it. Don't want to put that back. I'll put that back. All right. So says find the measures of A, C, and D, and they give us B is equal to 115. All right, so what we do want to recognize is that when it comes to the easiest angle to find, if we know B, then we know D because they're vertical angles. You know, this is equal to this, and then angle A is equal to angle C. All right, so I'm going to put my information back in there instead of rewriting it all. But that's the thought process. So then there we go. So if you look at D, D is 115 just like B was, because you see in blue, I'll give you the reasoning, because it's vertical angle with B. All right. Then it doesn't matter which one you decide to find next, whether it's A or C. I decided to go ahead and find A next. And A is a straight angle. That's what SA stands for. A is a straight angle with B. Remember, we go back to the notes, a straight angle is equal to 180 degrees. So we're talking about this is a straight line. If ever there's a straight line created, that's always equal to 180 degrees. All right. I could have left that. Always equal to 180 degrees. So that's what we did here. Yep. We did 180 minus 115. That gave us 65. And then once again, these two are equal, but also these two are equal. So if you know A, then you know C. And that's what we did right here. C is a vertical angle with A. All right. Problems with that before we go to the next one. Make sure we're good. All right, let's look at the next one. So we're going to talk about these relationships right here. Erase this circle. L1 and L2 are parallel, and T is a transversal. Transversal is just a line that, I still had my eraser up. There we go. Transversal is just a line that, intersects two lines like that. So that's what transversal means. So T is a transversal. All right. So we're looking at alternate interior angles as the first type of angles that we'll have whenever you have two lines that are parallel and are intersected by a transversal. So we're looking at D and X, and then C and W. So they're alternate, so they're on opposite sides or alternate sides of the transversal, and they're interior. So you're talking about on the inside. Okay. So that's what we mean by alternate interior angles, and they will be equal to each other. So once again, DX and then CW are alternate interior angles. All right, next one, alternate exterior angles, AY and BZ. So if you go back, you're talking about alternate sides of the transversal, but exterior. So they're on the outside. So AY and BZ. So those are alternate exterior angles. They're on the outside, three lines. All right. And the last relationship created from this relationship or this diagram or geometrical figure. Yeah, I think that's better. Corresponding angles are equal. Yeah, AW, BX, CY, and then Z is equal to Z. And so if I go back here, this cluster is equal to this cluster. A is equal to W, B is equal to X, D is equal to Z, and C is equal to Y. So they correspond to each other. All right. Any questions before we go to the diagram that's going to ask us to figure this stuff out? All right. So in the diagram, L1 is parallel to L2. So that's what that symbolism mean right there. And the angle or the measure of angle F is equal to 58. It says find the missing angles. All right, so let me erase this. So this is the diagram right here. Hold on 1 second. Sorry about that. Okay, so let's look at figuring this thing out. I have all the information. I guess we could just leave it there. All right, so we see that, and there are multiple ways of finding out these angles. I just, use different explanations here, but you didn't have to use these routes. We'll talk about what I've written and why they are where they are. So the first thing, you start off with F. We know F is given. F is 58 degrees. So now the easiest one to find from F is H, because H is a vertical angle to F. And that's what we have right here, is that H is a vertical angle with F. That's why it's 58 degrees. And there's no specific order. You don't necessarily have to go to H first. I just think that's the closest and the easiest one with no calculation. But that's between, you and your thought process. So H is 58 degrees. Then where I went next was, is it gonna let me do it? I was gonna let me do it. Was that, all right, it's not gonna let me do it. That's fine. I have a straight angle right here with F and G. And so that's what I wrote here. F and G are equal to 180 degrees. So you subtract 58 from 188. 58 from 180. And that'll give you 122 for G. And then we can find E, because E and G are vertical angles. So E should be 128. 122. So before we go to this cluster up here, A, B, C, D, questions on E, F, G, H. All right. Once again, it doesn't matter which route you go, as long as you get these same numbers. And also notice that we only have two numbers that we're dealing with, 58 and 122, right? So you just have to make sure that you're using the right terminology and right relationships in order to get them. So when you look at, this depends on which one you want to go to. Remember, this cluster corresponds to this cluster. So if you want to go 8, not 8, letter A, that's going to be 58 because it corresponds with F. B will be 122 because it's a corresponding angle with G. So remember, A and B equal to F and G. All right. And then if you want to keep going with your corresponding angles, you can. And what I decided to do is just switch it up. And since that's vertical angle with A, and then D and B are vertical angles with each other. But once again, you could have kept with the corresponding angles and said that D corresponds to E and C corresponds to H. Either way, you still should get 58, 122, 58, 122 for A, B, C, D. All right. Questions on those relationships? All right. Let me look real quick. I don't think you guys had triangles. Remember I told you I got these notes from my other class. I think you just have lines and angles. I think that's where you guys' notes were in for 6.1. Yep. Okay. All right. So before we go to the next section, questions. All right. So let's look at perimeter, area, and volume. Nope. So this is for you guys. It'll be 6.2 perimeter, area, and volume. So don't worry about that title. Just perimeter, area, and volume. All right. So let's look at a rectangle. And we're going to discuss all three of them first before we actually do examples. So we use a rectangle in all three to discuss the differences between the three, perimeter, area, and volume. So the perimeter is the outside. You know, you're talking about the outside of your shape. The siding, if you ever wanted to measure fencing, then that would be the perimeter. Or you set up a perimeter, you're talking about, you know, the outside. So you do not need a formula to calculate the perimeter. All you do is add up all your sides. Now, there are formulas for certain shapes, like the formula for the perimeter of a rectangle is P equal to 2L plus 2W, but you don't need it. All you have to do is add up all your sides. Okay? So if you ever have a shape and you want to find the perimeter, just add up your sides. Okay. So once again, that's the outside. Now, the area is the inside, the amount of space that a shape takes up two-dimensionally. And you do need a formula for that. Now, every shape has its own formula. So you wouldn't just use random formulas. You use the formula according to the shape that you're dealing with. So the formula for the area of a rectangle is length times width. But to calculate the area, you do need with a formula. And to calculate the volume, same thing. You need a formula as well, and that's the amount of space that a shape takes up three-dimensionally. So notice now we're including the height. So area is the amount of space that a shape takes up two-dimensionally. Volume is the amount of space that a shape takes up three-dimensionally. Also notice in the green, the measurement that you will be in after you've done your calculation. For perimeter, it would just be your regular measurement. If it's in inches, it's inches, feet, or meters. Your area, when you're done calculating, it will be squared. So your square foot, or square footage, or feet squared, inches squared. Then volume, once you're done your calculation, it will be cubic. So cubic inches, cubic feet, or feet cubed, and so on. Questions on the differences between the three? All right. So from there, it's just basically using the proper formulas. As a matter of fact, let me look up one thing before I go into that. Body okay? Yep, they're just asking you find the area. Oh, they didn't do any volume problems at all. Okay. So I said we have find the perimeter and area, and they give us the dimensions of 30 and 20 inches. So our length will be 30, width will be 20. So for the perimeter of the rectangle, you go ahead and use 2L plus 2W. 2 times 30, 2 times 20, 60 plus 40 is 100. And then to find the area, it's 30 times 20, which would be 600. So notice perimeter, our measurement is in inches. Area measurement is in is squared inches. All right, questions? Any questions? All right. Of course, if I scroll up too fast, let me know. All right, so here we have our diagram. Find the area of the triangle. Formula for the area of the triangle is 1/2 base times height. Establish what variable goes with what. So our base is 12. Our height is 6. So that's 1/2 12 times 6. And so that end up being 6 times 6, which is 36. All right. Any questions? Next one, find the area of the trapezoid. I don't want this to be red. I want this to be blue. All right, so the formula for the area of a trapezoid is 1/2 h times a plus b. So normally this top, A and B are interchangeable, but normally they give the top side as A, bottom side as B. So plug that into the formula. Now I was doing this by hand, so I took the easiest route. Whenever you're multiplying numbers together, it doesn't matter what order you do that, it's commutative. So I went ahead and took the half into 20, which was the easier calculation. So half of 20 is 10. Then 10 times 7 is 20. But if you took half of 7, that'd be 3.5. Then 3.5 times 20 would have gave you 70. So either way, you still should get 70. But that's why I had that error right there. All right. Questions, questions, questions. Let me see. I'm going to look at one thing. Oh, so now I made a mistake and went down. Because I'm not going to hold you accountable for stuff that they don't ask you for exact. Yep, they do ask for it. Cool. All right. So let's look at circles. So here we have, if your line goes from one end of your circle to the other end through the center, that's considered your diameter. But if it starts at the center and goes to one end of the circle, that's considered your radius. The relationship between the two is that your radius is always half of your diameter. Your diameter is always 2 times the radius. So if you know one, you automatically know the other. And they don't have to have these letters right here or any other, signification. That, that diagram, the line going from the center from end to end, lets you know you're dealing with your diameter. If it starts in the center and goes to one end, then that lets you know it's the radius. So just throwing it out there, they don't have to say the diameter is or the radius is. That diagram lets you know which one is which. So here, if I had my diameter as 30, then I know half of 30 is 15. That'll be my radius. Or if I knew my radius was 7, I want to know the diameter, multiply it times 2. That would be my diameter, which is 14. All right, questions? Any questions? All right. So we have the circumference and the area for circles. We have the circumference, which is the equivalence of the perimeter for circles. You're talking about the outside, not the space that is taken up on the inside, but outside, let's say fencing or whatever the case may be. We can't say add up all the sides when you talk about the circle because there are no sides, right? So the circumference is your equivalence of the perimeter for circles. So that's 2 pi r, 2 times pi times r. And then the area is pi times r squared. Pi, if you want to abbreviate it, is, where'd my stuff go? Okay. Pi, if you don't want to do the abbreviation, is 3.14, and that's the run-on decimal to infinity. So 3.14 is normally what is used there. All right. So directions here, find the exact find the circumference and the area, give the exact and the approximation. So notice what you start off with is this diagram going from end to end of the circle. And it says that, well, really you wouldn't have this either. All you would have is the diagram. And so they assume you know from the diagram that you know that your diameter is 20 inches. Now, according to the formulas that we have, we want to find the radius. So then we would take, how did it jump way back there? There you go. So then we would take half of that 20, which would be 10 for our radius. All right. Any problems so far? All right. So let's plug them into our formulas. We get one at a time. Let's look at our circumference over here. That's 2 pi r. Remember, it asks for the exact answer and the approximate answer. And let me erase this right here. That was from my other class. We don't need that. So 2 pi times 10 gives me 20 pi inches. So that is my exact answer. All right, with pi still involved, with the symbol of pi still involved, because pi represents that number on to infinity. All right, so that's going to be your exact answer. Simplify the answer as much as possible with pi involved. All right, so 20 pi is your exact answer. Now, when you put 3.14 in for pi, that's when it turns into an approximation. 20 times 3.14 will be 62.8. That's your approximation or your approximate answer. All right. Questions on those two answers right there. So simplifying your answer as much as possible with pi still involved is your exact answer. Plug in 3.14 and then multiply. That will be your approximate answer. Then we do the same thing for the area over here. Pi times r squared. Plug in 10 for r. 10 squared is 100. So 100 pi will be your exact answer. Now to find the approximation, plug in 3.14 and multiply, and that'll give us 314. Don't forget we're inches squared for your area, regular inches for circumference. All right. Questions. All right. And let me put that back. That's for my other class. Any questions on this before we go to volume? Anybody still copying? All right. So the next one, we'll find the radius of the base of a cone. Oh no, the radius of the base of a cone is 8 centimeters. The height of the cone is 12 centimeters, and it tells us to find the volume. So this is the diagram right here. So we got the height is 12 centimeters. The base is 8 centimeters. All right. So the formula for the volume of a cone is 1/3 pi r squared h. So I'm not sure if they're going to ask you for exact. Normally when they do exact approximation, they do that for the circle, but they may ask it for the cone as well. So what I did was I simplified as much as possible right here. Took the 1/3 into 12. 3 divides into 12, leave you with 4. 4 times 64 is 256 pi. So always remember If they ask for the exact answer, your exact answer is your answer simplified as much as possible with the symbol pi still involved. So the symbol pi is still there. Then if you want the approximation, you plug in 3.14 for pi, and then do your multiplication, and that's how you get 804.25. Also watch the measurement. Notice we're cubic centimeters now. All right. Questions before we look at the next one? All right. So we'll do this one, then we should be good to go in volume. They didn't do many volume problems, but it's basically about finding your finding the formula. There you go. Find the formula that goes along with the actual shape that you're dealing with. So that's what it's all about. All right. So here we have a cylinder or a can. Can and cylinder are pretty much the same. They give us the height, which is 4. Diameter. Notice the diagram once again goes from end to end. Always make sure you pay attention to that. Because if it didn't go from end to end, if it started at the center and went to one end, then that would be your radius. Since they gave us diameter, then we can go ahead and do our calculation. 1/2 of 6 is 3. And that is our radius. Formula for cylinder is pi r squared times h. Plug in the values. 3 for r, 4 for h. So that's 9 times 4, which is 36. 36 times 3.114 will give you 113.1. Once again, that right there is your exact answer. All right, questions. Area, perimeter, or volume. Any questions? All right. So now, all right, let me write this like this. Section is 30. So I'm going to do these together because to break them up, it's kind of funky when you're talking about them. So the next sections, and really they could have been all in one section. That's why there's normally set up like that. But you have 6.3 is linear measurement. 6.4 is weight and mass. And 6.5 is capacity. All right. So we're going to talk about them all together because to me it doesn't make sense to break them up. Not while you're trying to talk about them, but when you're doing assignments, then that makes sense because you're just focusing on linear, just focusing on mass, just focusing on capacity. So when we get here, your linear measurement will be meters. When we're talking about the metric system, weight and mass will be grams, and capacity will be liters. But the way you convert between all of them are going to be the same thing. You'll see what I mean in a second. All right. right, so everybody copy the titles. I good with the titles. All right. All right, so let's looking at U.S. measurement. It's called U.S. measurement because mainly the U.S. uses it. When we get to the metric system, that's the system that the world leans on. So U.S. measurement, we have these conversion factors. So 12 inches is equal to 1 foot, 3 feet is equal to 1 yard, 36 inches equal to 1 yard, 5,280 feet is equal to 1 mile. So these are just a few of them. Of course, these are not all of them that we use, but these are just a few of the conversion factors. So we will use these to convert our measurements. Like I say, if I have a certain amount of inches and I want to go to feet, I would use, 12 inches is equal to 1 foot in one way or another. So if I want to go from inches to feet, I have 18 inches. Let me erase this stuff. All right, so if I want to go from inches to feet, I probably shouldn't erase that. I would find the conversion factor that deals with inches and feet, which is right here. So now I can set this up one of two ways. Either I can use inches over feet or feet over inches. All right. So now what will dictate whether I use inches over feet or feet over inches is the fact that I have inches that I'm starting off with. So what you need, if you have inches in the top, you need inches down bottom. So the one I'm going to use is this one right here. And it leans back on the idea of, when you cancel out fraction or reducing fractions. If you have a 2 in the top and cancel out with a 2 in the bottom, it's the same thought process. All right. So let me put back what I had. So I have 18 inches. You place that over 1. Then I use the conversion factor of 1 foot over 12 inches. Once again, I want to make sure that my inches were in this denominator so that they can cancel out with the inches in my numerator. And notice that leaves me in feet, which is what I wanted to get to. So they cancel. And like I said, it leaves me in feet. So that's 18 over 12. That's 1.5 feet. And here I was just saying, it depends on how they want the answer. You could have left it in fractional form and reduced it. 3 over 2 is the same thing as 1.5. So I think that day somebody had asked about that. Questions on what we did there before we do another one? So if there's any type of conversion other than the metric system, even if you're going from US to metric, this is the thought process. If it's strictly the metric system, you'll see what we'll do with that. But if it's anything going tons to pounds, quarts to gallons, this is the thought process. This is the foundation of what you'll be doing. Take the conversion factor, and whatever you start off with, that needs to be down bottom so it can cancel out. And of course, it needs to connect with the one that's up top right here. And then we go from there. And you can keep using conversion factors as till you get to the measurement that you want to end in. So it depends on what you're doing. All right. So let's look at the next one. If you have 14 feet and you want to convert that to yards, conversion factor, 3 feet is equal to 1 yard. So I'm starting off with feet. So I need feet down here in bottom so they can cancel out. Didn't need to do that. So my feet cancels, and that's 14 over 3 yards, which is 4.6 repeated. Now, some people, if you deal with measurements and conversion factors all the time, you don't even need this, you just flow with it. But, for those of us who don't, this secures us using the right process, because either you're going to divide or you're going to multiply by that 3. So doing it this way secures whether we divide or multiply by 3. All right, questions. All right, next one, tons to pounds. So they gave us 3.5 tons to pounds. I went ahead and converted that mixed number to an improper fraction. 3 times 2 plus 1. And there are 2,000 pounds in 1 ton. So that's what I did. I had tons initially. So I needed tons down in my denominator. Multiply across. Tons cancel. So that's 7 times 2,000, which is 14,000 over 2. And that's 7,000 pounds. Any problems? All right. So looking at the metric system, and we'll come back to that because I believe I got some up here when you're going from metric to US, US to metric. Metric system, you know, here are your basic prefixes: kilo, hecto, deca. Then our base, you know, that's going to be grams, meters, or liters. Kind of mentioned them earlier. Grams, meters, or liters will be your base, depending on what you're measuring. Deci, centa, and milli, or milli. Anyway, those are the abbreviations right here in the middle. And then the value 1,110, 1, 1/10, 1 100, 1 1,000. And of course, these prefixes, this metric system get very, very large and very, very small. As far as large, you guys, I'm pretty sure for those of you who bought a cell phone, you know, you heard of megabytes and gigabytes and all that stuff like that. So also, you know, you're talking about very small nano, you know, nanotechnology, you know, pico. Those are very, very small prefixes. But these are the ones we're dealing with, just the basic ones. Each one of these prefixes can be placed in front of either one of the bases. Once again, what base we use will be dictated upon what we're measuring. All right. All right. So grams is weight, meters, length, liters will be your volume or capacity. And I mentioned that earlier. G's for grams, M for meters, L's for liters. That should be lowercase right here. Stay consistent. And here, just emphasizing that either one of those prefixes can go in front of either one of those bases. So you have kilograms, kilometers, or kiloliters, or centigrams, centimeters, or centiliters. All right. So what will be your success dealing with what is it called? Metric system will be dependent upon you remembering the order of your prefixes. You know, when we talk about here, notice that they're only separated by multiples of 10. So you got 1,000, 100, 10. You divide each one of them by 10, you keep going down, or multiplying by 10, you keep going up. So they're separated by tens. So that's just the moving of your decimal. So if you remember the order, and the way we can do that is by King Henry died by drinking chocolate milk. If you can remember that King Henry died by drinking chocolate milk, then you will be able to, hopefully you'll be able to remember the order of your prefixes. So K for kilograms, or not kilograms, but kilo, H for hecto, D for deca. Then B is for your base. So whatever base you're dealing with is what B represents. Then you have deci, centa, and milli. All right. So, and the reason why this is why I said that, splitting them up as far as your lecture is concerned, splitting them up into three different sections doesn't make sense, because it's the same process whether you are dealing with weight, length, or capacity. It doesn't matter. It's still the same process. Remember the order and then move the decimal accordingly. All right. So, looking at the first one, we want to convert 0.38 meters to millimeters. All right. So, like I said, remember the order. King Henry died by drinking chocolate milk. All right, so that's why I have kilometers, hectometers, decameters, meters. That's your base. Decimeters, centimeters, millimeters. All right. So you start at your meters and you go however many places it takes to get to millimeters. So I started at meters and I went 1, 2, 3 to the right in order to get to millimeters. So then that means I'm going to take my decimal and go 3 to the right. And that gives me 380 millimeters. Notice we use a 0 right here as a placeholder because we only had two values. So you move three values, you're gonna have an extra space, so you need that 0 as a placeholder. All right. Questions on that? All right. Same process. We have 12.9 centimeters, and we're going to go to hectometers. Start at centimeters. Once again, remember the order. King Henry died by drinking chocolate milk. Remember the not remember the order, but start at centimeters. How many spaces or how many times do you move to the left to get to hectometers? And it's 4 to the left. So we start at decimal, move 4 to the left, and we have 2 zeros that we have to use as placeholders, and that'll be 0.00129 hectometers. All right, questions, questions, questions. Make sure we're okay. All right, same thing with grams. So if I have 4.23 decagrams, excuse me, you want to go to centigrams. Only thing that changes is that we are using G's, grams instead of meters. Process is still the same. Kilograms, hectograms, decagrams, grams, decigrams, centigrams, and milligrams. So how many spaces do I move to the right in order to get to centigrams from the decagrams? And it's 3. I went 3 to the right. And 4.23, take that decimal 3 places to the right, use 0 as a placeholder. It's 4,230 centigrams. All right, problems, any problems? Same thing with liters. So if we have 1,579.64 milliliters and we're going to hectoliters, you just replace an L where the G or the M was. 5 milliliters. How many spaces to the left are you going to move in order to get to hectoliters? This time it was 5 to the left. So we took our decimal 5 to the left, ended up having to use 10 as a placeholder. So it's 0.0157964 hectoliters. All right, problems with the metric system. Make sure we're good. All right, so now if we want to do US to metric, since there's no real connection like we just did previously, we would do the same thing that we did initially. In other words, we would set up our fraction, find a conversion factor, then set up our fraction, and then just multiply accordingly. So let me erase this. So if we want to go 55 miles to kilometers, miles is US, kilometers is metric. So you find a conversion factor. So these conversion factors should be in your book, even when it comes to the ones we talked about previously or initially. All those conversion factors should be in your book. Or if you don't feel like pulling out the book, you can ask Siri, you can ask Google, ask Alexa. They all the same. They don't change. So everybody knows these conversion factors, whether you're talking about US, if you're talking about your metric system, or if you're talking about US to metric, all of it stays the same. So there are 1.6 kilometers in 1 mile, or 1 mile is equal to 1.6 kilometers. Anyway, and so set it up accordingly. Notice that we're starting off in miles. So we have miles down bottom. They cancel, multiply across, and that's 88.55 kilometers. So once again, that's the same process that we used in the beginning. You just need to know the conversion factors. All right. Questions on anything? Questions on anything else need to be? Do I need another example? Are we good? Are we good to go to temperature, which is our last thing for tonight? All right. So let's do this. Last thing for tonight is temperature. Yep. Oh, this is temperature control. Okay. What's the temperature? Now it's titled temperature and conversion between US and metric. So we already did the other part. The only new piece that we're talking about now is the temperature part, but the conversion between US and metric is going to be in 6.6. The last thing we talked about. The other ones just keep it straight, either just straight US or straight metric. We talk about 6.3, 6.4, 6.5, but then the conversion between the two will be in 6.6. But once again, the process is still the same. So just want to make sure on the temperature formulas that they're using, if it's just Fahrenheit and Celsius. Or they're using Kelvin. Okay, there we go. All right, so we got Celsius to Fahrenheit. Yeah, we can do the or. All right, so we're talking about Celsius to Fahrenheit, 9.5 times C plus 32, or you can go ahead and use 1.8 times C plus 32. Either way, you'll get the same result. Won't have the same luxury when we go the other way around. You'll see why in a second, but yep. So I'll show you how to use that. All right, so the directions could be use 15 degrees Celsius to convert 15 degrees Celsius to Fahrenheit. So you're going to take 15, plug it into the equation where you see C. Now, as far as putting this into the calculator, there's 9 times 15 divided by 5. You can do it that way. So 9 times this number divided by that number. So 5 goes into 15. That's supposed to be red. So if I was doing this by hand, though, I would divide the 5 into the 15. Just give you 3. Then 9 times 3 is 27. 59 degrees Fahrenheit. All right. Questions before we do at least one more. Make sure we're good. All right. Next one, same thing. 29 degrees Celsius. We want to convert it to Fahrenheit. We can use the other formula, other form of the formula. So it's 1.8 C plus 32. Like I said, it doesn't matter which one you use. So it's 1.8 times 29. Yeah. 1.8 times 29, 52.2. That is 84.2 degrees Fahrenheit. All right, any problems with Celsius to Fahrenheit? Nope. All right, so the next one, Celsius is equal to 5/9 times F minus 32. So now there's not an or on this one. You have to leave this as 5/9 because 5/9 is a run-on decimal. That's going to be 0.5 repeated. So they don't do an or on that case. The other one was a terminal decimal. 9 divided by 5 is 1.8. That's why you could use the decimal value. They do not want to use the decimal value in this case because you will have to round it off or truncate it. And then, you know, somebody might use 0.56, somebody might use 0.6, somebody might use 0.556. And the more decimals you use, the more accurate you are. So, you know, that's why they don't do an or when it comes to the other side of the formula or converting from Fahrenheit to Celsius. All right. So let's go convert. $59. So convert 59 degrees Fahrenheit to Celsius. All right. So you plug it in. So 5/9 is equal to 59 minus 32. Don't forget order of operations. You have to do what's in the parentheses first. So it's going to be 27. Once again, if you want to put in your calculator, the easiest way to do it is 5 times 27 divided by 9. If I wasn't using the calculator, doing it by hand, I recognize that 9 can go into 27. Leave it with 3. 5 times 3, 15 degrees Celsius. All right, problem before we look at one more. And that is it. That's it. So let's go from 114 degrees Fahrenheit to Celsius. So that's 5/9 times 114 minus 32. Once again, do what's in the parentheses first. That'll be 82. And 9 doesn't go into 82 evenly, so I would go ahead and throw this in the calculator. 5 times 82 divided by 9. And so that approximately be, and always pay attention to my math lab, see how many decimal places they want. This one says 4.5 or 45.6 degrees, and that'll be Celsius, of course. All right. Questions on temperature. Make sure you're okay. So those are only 2 temperature scenarios that they give. Anything, anybody. All right. All right. So, you know, that's it for chapter 6. Try this stuff out. See if you get stuck. Next class, I'll open the floor for questions first. See if you have any issues on anything before we go any further or do anything else on next class. So before we close out today, questions, concerns, comments, anything, anybody? Everybody good? Everybody straight? All right. So don't forget, You can email me if you have any questions that may pop up. And we can go from there. All right. So you guys have a good one. You be safe. Mr. Staten, is it Staten or Staten? Staten.
Stay. Yeah,
Okay.
yes.
Nice to meet you, sir. Nice you finally got
Nice to
in.
meet you. Yeah. All
So
right.
you guys have a good one. Be safe. And I will see you on next class.